Hi everybody, it's me, Dr. V, and it's a great day to get ready for the AP Chemistry exam. Now, I've been teaching AP Chemistry for over 20 years at this point, and I've got a lot of strategies and tips to help you write better responses to free response questions on the AP Chemistry exam. That's what we're going to focus on today. It's less about content and more about test taking. Now, the 2026 exam will be given as a hybrid exam, just like the 2025 exam. So your online questions will be on your computer in Blue Book. You'll have a paper answer booklet where you can record all your answers. One thing that's new for this exam is that there will be two versions of the free response questions that are being pushed out to students during the live test session. My understanding is that they're called J and K. I'm not kidding about that. In the test booklet, you're going to have pages for both versions, for question 1 in version 1 and version 2, and question 2 for version 1 and version 2, and so on. So you need to make sure that you're writing your answers on the appropriate pages that correspond to the version that's in Blue Book for your exam. So pay attention to that. For each free response question, you need to realize that each part of each question has its own space where you should be writing your answer, and do try to write your answer in the correct section. The readers are going to look through the whole question and try to find any information that you've got there, even if it's out of place, but make it easy for the reader to find your answer. The other thing I want to point out is that any diagram that you're going to need to draw on or annotate or complete in some way will be included in your answer booklet. That's actually very helpful because A, you don't have to try and sketch it yourself, but also your question part B has a diagram and you turn to the page in your answer booklet and you don't see a diagram, maybe you're in the wrong part of the booklet. Make sure you're on the right page. In terms of test-taking strategies, you want to make sure that you're not spending too much time on any one question. It's a very long exam. You have 7 questions to do in 105 minutes. The first 3 questions on the exam are long questions, 10-point questions. So questions 1, 2, and 3, I'm recommending on your first pass through the exam that you spend 18 minutes on them and then move on. Be prepared to switch topics as you're working through the question. For the short free response questions, 4, 5, 6, and 7, which are worth 4 points each, I recommend that your first pass through those questions, you spend 7 minutes and then move on. There will be a timer in Blue Book to help you keep track of your pace. So, note your start time, when you need to move on to the next question. And part of what I want you to think about here is that you want to make sure that at the end of the time slot for the free response questions, that you have 10 or 15 minutes at the end of the exam to go back and finish any questions you hadn't answered, double check your work, fix a calculation that you realize you made a mistake on. And that's where the pacing becomes really important. You don't want to get bogged down in one question and then not have time to finish something that was easy later on. In that same idea, you want to make sure that you're not spending too much time on any one part of any single question. Some parts are really easy. Go ahead and just answer them. Your goal is to earn as many points on this exam as you can. And the first part of any free response question is usually very accessible. It's one of the easier parts of the question. And you're going to find that some of the parts of a free response question are really straightforward. It's stuff you should know. They're core skills. You can go ahead and just answer them very confidently. Do expect that somewhere in the test there could be a part of a question that has a creative twist and an unexpected approach to using some of the skills and content that you've been studying this year. That's fine. There's nothing in there you don't know how to do, but it's going to ask you to think about it in a new way. I also want to remind you that you don't have to do the question parts in any particular order. Do those easy ones first. If you're not sure what to do for a particular part of one question, flag it. You can come back to it later, move on to other questions, go answer those easy ones, come back to them later, and work on the tricky parts at the end of the exam. You do want to try and make sure you answer each part of each question. You want to try and have at least something written down. Don't leave large sections blank. You do want to also keep your answers brief and relevant. You don't need to restate the question. Don't waste your time writing unnecessary information. If the question just asks you to state something, get right to it. Don't hesitate, just write it down. Only write explanations if the question specifically prompts you to do that. A, you don't have time to waste, and B, you don't want to risk contradicting yourself or writing down something wrong that's off topic that unfortunately causes you not to earn that point. Along these same lines, bullet points for free response answers are fine. There's no requirement that you write complete sentences. You're not writing essays here. Bullet points are your friend. But keep your answers concise. If you find you need to write more than 3 or 4 bullet points to answer one part of one question, you're probably writing too much. As an example of a question where you just need to state the answer. This is a question from the 2022 exam. Using the information in the graph, estimate the pKa of this acid from the titration curve. Looking at the curve, you might recognize that the equivalence point was reached at about 10 mils of titrant, which means the half equivalence point is at 5 mils, and what we really need is the pH at the half equivalence point. And the pH at the half equivalence point is 3, so the pKa is about 3. And that's all you had to write down. You were not asked to write an explanation, just give the answer. Don't waste time and don't go down rabbit holes that aren't going to help you. In general, you want to make sure you're very clear about what substance or substances you're discussing, especially in questions where it asks you to compare two substances or two species as part of the question. What are you talking about? Be very clear here. Write down the formulas or write down the names, whatever's going to be quicker for you to write down. Try not to say it. That's just going to lead to confusion. Do you remember which one is which? Will the reader know which species you mean when you say it? Probably not. It's best not to go there. It does mean that your sentences or your bullet points might be kind of clunky. I don't care. That's fine. This is not AP Lit, where there are style points and you can actually get a slightly better score if you said it extremely well and very eloquently. That's not our target here. We want to be clear and concise and accurate. For example, from the 2022 exam, there was a question about comparing IMFs. The same three types of intermolecular forces exist among molecules of these two substances. So we have methyl salicylate and salicylic acid. And they have very different melting points. Explain why the melting point of salicylic acid is higher than that of methyl salicylate. And you can see they're very, very similar structures. Now, the gist of this question was really that higher melting points are a result of having stronger intermolecular attractions between the molecules. So we need to compare what's going on in these molecules. See that each molecule has 3 oxygen atoms that could accept a hydrogen bond from another molecule just like it. So that's not going to help us. But when we look at methyl salicylate, it has 1 hydrogen atom that could form a hydrogen bond with another methyl salicylate molecule. Salicylic acid, however, has 2 hydrogen atoms that could form hydrogen bonds with another molecule. So our answer is really what I'm highlighting here in blue. Since salicylic acid can participate in more hydrogen bonding between molecules than methyl salicylate can, the IMFs between salicylic acid molecules are stronger than the IMFs between methyl salicylate molecules. Know it. Is it clunky? Yeah. Is it a little repetitive? Yeah. Does it say what I need it to say? Also, yeah. You also want to make sure that you are doing what the question is asking you to do, and you're not going off track here. Don't go down rabbit holes of giving me related but irrelevant information that doesn't actually help you answer the question. You want to stay on topic and avoid issues that aren't part of what you are being asked to do right now. Make sure you're using the information given to you in the prompt. Don't overlook that. Don't overlook the diagrams in the prompt. If you're given a specific data point, make sure you use it. You may need to refer to it in your answer, either as part of a calculation or to explain what's going on. Don't tell the readers that the question is giving incorrect information or that it's wrong in some way. No, that's not true, and it's certainly not going to earn you the point. If you need to use a previous answer, go ahead and do that. Be consistent with your previous answer, whether that was a calculated value or some other situation. Don't contradict yourself. It's probably going to cost you the point. So let's look at an example of this. This is from the 2024 exam. There was a question about plating out rhodium metal from a solution. And you're told in the question prompt that you're depositing solid rhodium onto the surface of the metal. And you're asked to actually write a balanced net ionic equation for plating rhodium metal from this solution. And you're given 2 half reactions. So we need rhodium metal to be a product, which means we want to keep the rhodium ion half reaction. You can just write that down. We're also told in the prompt that oxygen gas is produced. And we have a half reaction with oxygen in it, but it's got oxygen as a reactant and we need it as a product. So we need to flip that oxygen half reaction in order to write the overall balanced equation. So we can flip the equation. We need to make sure that the number of electrons lost equals the number of electrons gained. So I'm going to multiply the half reactions so that the electrons will cancel out and add everything up. But we're literally told that oxygen gas is a product, and so we need to have oxygen gas as a product. We're told that rhodium metal is a product. We need to have rhodium metal as the product. The question stem may have more subtle clues about what it is they're wanting you to do, sometimes not so subtle. If the question talks about answering it in terms of atomic structure, folks, you're going to either need to discuss the number of occupied energy levels or talk about nuclear charges in your answer, comparing that maybe for 2 species. If the question talks about explain it in terms of particle level reasoning, you need to have the word particles in your answer. And if you're talking about entropy, You want to talk about the number and states of reactant particles, the number and states of matter of those product particles, and talking about the change in available microstates. If the question says, discuss it in terms of Coulomb's law, you're going to need to either discuss the effect of charge magnitudes on the strength of attraction, or the effect of interparticle distance on the strength of attraction, or maybe both. Answer what the question is asking you to do. For example, here's a question from the 2022 exam. Based on principles of atomic structure, explain why the radius of the aluminum atom is larger than the radius of the aluminum ion. Principles of atomic structure, there's that clue. The neutral aluminum atom, we can write out its electron configuration. An aluminum ion, you'll see, has 3 fewer electrons, right? We're going to lose those outermost electrons. So in a neutral aluminum atom, the highest occupied energy level is energy level 3. And in an aluminum ion, the highest occupied energy level is energy level 2. And that's really the gist of what your answer needs to involve. The outermost electron in a neutral aluminum atom occupies energy level 3, which is farther from the nucleus than the outermost electrons in the aluminum ion, and those are in energy level 2. Hence, the difference in radius. Remember not to use one periodic trend to explain another. That's not going to work either. Another example from the 2024 exam. The reaction shown below has a value of delta S that's greater than 0. Using particle level reasoning, explain why the entropy increases as the reaction progresses. There are 3 moles of reactants. They're all in aqueous solution. For the products, I have 5 total moles of products. 2 of them are gas, and 3 of them are still in a condensed phase, so I've got some liquid and some solution. And the words liquid and solution are not interchangeable. I have more moles of product particles, and I have moles of reactant particles, and I've got 2 moles of gas being produced. Therefore, there are many more available microstates for the product particles than there are for the reactant particles. So we've got the word particle. We're using particle level reasoning. Very, very much what we needed to do for this question. The entropy of the products is greater than the entropy of the reactants. Don't discuss disorder when you're talking about changes in entropy. That will not get you credit. Talk about increased number of possible arrangements or fewer numbers of possible arrangements or microstates. That's the way to go. Anytime you're asked to do an explanation, that you're talking about it in terms of chemical principles. Definitions are not going to cut it. You're not actually ever going to be asked to just define terms on the AP exam. You have to explain why it's relevant for this question and do it in a conceptual way. You want to talk about evidence and reasoning. We've talked about CER. That's always a good advice here. Restating an observation or just listing a law without tying it into the question and explaining why it's relevant is not going to get you the point. Let's look at an example from the 2019 exam. A student is doing experiments with carbon dioxide gas. Originally, a sample of the gas is in a rigid container at 299 Kelvin, and the pressure is 0.70 atmospheres. The student increases the temperature of the carbon dioxide gas in the container to 425 Kelvin. In terms of kinetic molecular theory, briefly explain why the pressure of the CO2 gas in the container changes as it is heated to 425 Kelvin. So we want to make sure we're doing it in terms of kinetic theory, particles moving, right? We know that as temperature increases, the particles will have a greater average speed. Because they have a greater average speed, the particles are going to collide with the container wall more frequently. It's not about colliding with each other, it's about colliding with the container wall. We also know that the particles, when they do collide with the container wall, are going to collide with more force. You needed to have one of these 2 statements about collisions with the container wall in your answer. If you just said that, oh, well, pressure and temperature are directly related, well, you're just restating a gas law. You're not doing it in terms of kinetic theory. So you want to make sure you answer the question being asked. You do want to make sure that we can read your answer. So you can have a really high quality answer. If I can't read it, I'm going to have a really hard time figuring out how many points you've earned. We're going to try to read it, but make it easy on us. All right. So make sure your writing is legible. Write neatly. If you're using common abbreviations, that's fine. If you want to write LDF for London Dispersion Forces, no problem. If you're using a new or unusual abbreviation, you might want to tell us what it is. Just give us a little clue. We're going to try and give you as many points as we can. If you've made a mistake in your answer and you can't erase it cleanly, or you're writing in ink, cross it out and rewrite your answer. If you have a lot of erasures on your page, it makes it very hard to read them. We only see the scanned pages. All the pages from your book are going to get scanned and they get sent out to the readers. If there are lots of erasures, it makes it hard to read. That's especially important when we're trying to look at Lewis structures. If you've got a lot of stray marks or a lot of erasures around Lewis structures, Was that a line? Was that a dot? What's going on? Try to make sure that you're doing that as little as possible in terms of lots of erasures. You are going to write in blue or black ink or number 2 pencil for your entire exam. You can't bring in highlighters or anything like that. If you know that you write very, very lightly, you might consider writing text-based answers in blue or black ink just to make them a little more legible. Vocabulary continues to be important. If you're talking about atomic structure, you really need to be talking about atomic energy levels or shells, and don't call them periods. The horizontal rows in the periodic tables are not the same thing as occupied energy levels or shells in the Bohr model. Now, I know with my students, I have a tendency to anthropomorphize things to make it a little more engaging for my students, but atoms and molecules aren't alive. They don't want to do anything. They don't like to do things. That's not a phrasing you should be using in a written formal exam. Instead, write has a tendency to, and that'll be fine. We also shouldn't be talking about atoms being happy. That's not good chemistry, right? So we don't want to say that they're happy when they have a full octet, okay? You can talk about stability or lower energy states or whatever's relevant, but please don't give them emotions. That's not going to earn you credit. If you're establishing or reestablishing equilibrium, your best bet is to talk about the system proceeding in the forward direction to make more products, or proceeding in the reverse direction to make more reactants, instead of saying a shift left or a shift right. We can tie this into the idea of Q versus K. Q and K are not interchangeable terms either. Q is the reaction quotient, it can change, and K is the equilibrium constant, and it's fixed. If Q is greater than K, the system's going to proceed in the reverse direction. Why? I've got too many products, I need more reactants to establish equilibrium. If Q is less than K, the system's going to proceed in the forward direction. I've got too many reactants, I need more products to establish equilibrium. And the reason I say this is because if you weren't at equilibrium and there is some stress on the system, or you've never been at equilibrium because you just set this system up, you can't call it a shift in equilibrium because that implies Le Chatelier's principle. And if you weren't at equilibrium, it's not relevant and it won't get you credit. It's always okay to say proceeds in the forward direction, proceeds in the reverse direction. A number of the questions that you'll be asked to do on the AP Chemistry exam, of course, will be calculations. It's a calculation-intensive course. You always want to make sure you show a complete setup. You have to show numbers substituted into a relevant equation for that problem. You don't show the work, you don't show a setup, you won't get the point. Even if your answer is correct, you just cost yourself an easy point. Don't do that. Any valid strategy or approach is fine. There can be more than one way to set up the problem, more than one way to work through the problem. That's fine, as long as it's a valid approach relevant to that question. You do want to make sure that your units and your answer correspond. The common place here is joules versus kilojoules. And if you're given a value in the problem, a concentration, a mass, what have you, if you need it in your calculation, make sure you use the number you were given. Don't go making other problems up or other values up. An example of showing work for a calculation, here's one from the 2022 exam. A single photon with a wavelength of 4 × 10 to the minus 7th meters is absorbed by a sample of silicon. Calculate the energy of the photon in joules. The equation that's relevant here is E equals hc over lambda. We can put the two equations together, or you could do it stepwise. It's all good. You don't actually have to show the equation. That's not a requirement. Showing substituted values that are relevant, that's required. So I've got Planck's constant, I've got the speed of light, I've got the wavelength that I was given, I've shown enough work, an appropriate setup, and I can get an answer of 4.97 × 10 to the minus 19th joules. Students will often ask, hey, Dr. V, do I need to put in the units in my setup? No, but it's a good idea because if you put all your units in, it's very easy to see that seconds cancel out. It's very easy to see that meters cancel out, and I'm left with joules. And that's a little clue that I did set everything up correctly. So it helps you, but it's strictly speaking not required. Vocabulary, again, will continue to be important if you're discussing size changes as part of your problem. Talk about whether it's becoming more massive or less massive. This is really important when we're talking about electrodes in a voltaic cell. For example, the anode becoming less massive as the cell operates. It's not a volume effect, it's the mass that's changing. This becomes relevant when you're talking about intermolecular forces, particularly London dispersion forces. You want to talk about more polarizable or less polarizable electron clouds. And you want to back this up based on more electrons in your electron cloud or fewer electrons in your electron cloud, making it easier to distort that electron cloud. It's not the volume of the species or the mass of the species when you're talking about London forces. Continuing with this idea, we want to make sure that if we're talking about intermolecular attractions, London forces, dipole-dipole attractions, hydrogen bonds, etc., that we're not confusing them with covalent bonds between atoms in the same molecule. So be very careful with that wording there. And ionic compounds should not ever be described as molecules. The word molecule implies covalent bonding. You certainly don't want to be discussing single, double, and triple bonds or sigma and pi bonding if it's an ionic compound, a metal with a nonmetal, or a cation with an anion. A very common question type that you'll definitely see during the exam is a question where you have to make a claim and then back it up. You do want to lead with your claim. It should be at the top of your response. I actually typically write that last when I'm answering these questions because I like to work through my reasoning. I find a claim, evidence, reasoning format to be really helpful here, and then I'm going to circle my claim to make it really easy for the reader to find. If your claim's incorrect, you're not going to earn the point. So you really want to make sure that your evidence and reasoning are sound. You want to make sure that you're not contradicting yourself either. If you have a correct claim, but then your explanation and justification don't match that, either contradicted or just plain off topic, again, you're not going to earn that point. Another question type that we see that really falls into this making a claim category are questions involving lab experimental error. You want to talk about what measurement was affected in these cases and how would that change, say, the calculated value. You do want to make sure when you're making a claim that you're using the same terms that were in the question. Did the question ask you to agree or disagree? Did it ask if the value would increase, decrease, remain the same? Does it say that the answer would be greater than a certain thing, less than, or not affected? Make sure that you're using that same phrasing. For example, from the 2024 exam, there was a calorimetry question. There was a long free response question. This is just one part of it. A student claims that if heat is lost from a calorimeter to the surrounding air during the reaction, the experimental value of the molar enthalpy of reaction will be smaller in magnitude than the actual value. Do you agree or disagree? Justify your answer. So we need to make sure we back this up. It's not just agree or disagree. That's not going to be enough. Since this is part of a calorimetry calculation where we had already done some parts of it, we need to use Q equals MC delta T as part of our reasoning to calculate Q. This is a lab error analysis. What measurement would be affected? Well, the measurement that would be affected if energy is lost to the surrounding air is the final temperature. T final is going to be lower. And if T final is going to be lower, then delta T is going to be lower. And if delta T is a smaller magnitude, then Q is going to be a smaller magnitude. And this is all relevant because we want to calculate the molar enthalpy. And the molar enthalpy would be the Q value with the opposite sign divided by the moles. But Q has a smaller magnitude, and Q and delta H are directly proportional. So if the magnitude of Q is smaller, then the magnitude of delta H will also be smaller. The end result is that, yes, I agree with the student's claim, but notice I did all my reasoning first, and I put my claim at the top, even though it's the last thing I wrote. In AP Chemistry land, again, vocabulary is so important, and justify and explain mean different things in the context of this course. Justify usually means support your answer with math-based reasoning or support it based on data. It may involve a calculation. Sometimes you'll be prompted to do that. Sometimes you'll find that it's faster to write out your reasoning instead of doing a long calculation. So that's context dependent. It could refer to specific details about data or a graph or a table. It might give you that information, and your justification would need to refer back to those specific details, whatever's relevant. Explain is much more conceptual. It means support your answer based on a theory or a conceptual understanding. You don't want to just restate the theory. You do need to actually relate it to the situation. Let's look at some examples. From the 2023 exam, there was a question about acids and Ka values. The following particulate diagram represents the ionization of one of the acids in the table. So we have 3 acids. Water molecules have been omitted. Which acid, HNO2, HCl, or HClO4, is represented in the diagram? Justify your answer using the information in the table. Now this is a particle level diagram, and that means always count your particles, folks. And we then need to make sure that we do refer to the table in our final answer. Looking at the diagram, I see that there are 7 HA molecules. I've got 1 hydronium ion, 1 A- ion. So there were 8 molecules of HA originally, and 1 out of the 8's dissociated. Well, that's about 13%. Most of the molecules are HA. So that tells me I have a weak acid. And I'm going to have a very small Ka value. I don't have to calculate the Ka value, but the fact that most of the molecules are still intact HA molecules tells me that Ka is less than 1. And there's only one acid in the table with a Ka value less than 1. And so my diagram must be representing HNO2. That's my claim. And it's the only acid in the table that's got that small Ka value that could be a weak acid. Here's an example of explaining your answer. This is from the 2021 exam. At high temperatures, the compound silicon tetrahydride decomposes to form solid silicon and hydrogen gas. And there were other parts of the question that asked you to write out a balanced equation, etc. The reaction is thermodynamically favorable at all temperatures. Explain why the reaction occurs only at high temperatures. Thermodynamically favorable is telling us that delta G is negative. This reaction energetically makes sense. Why are we only seeing it at high temperatures? That's the explanation piece we need. The reaction must have a very high activation energy, right? That minimum energy needed for the reaction to occur when the particles collide. Only at high temperatures will a significant fraction of reactant molecules have enough kinetic energy to overcome that activation energy minimum. So at low temperatures, we're not going to really see a reaction. At high temperatures, enough of them are over the minimum and the reaction can proceed. Again, vocabulary continues to be important. The College Board prefers the terminology that a reaction is thermodynamically favorable. They don't use the term spontaneous. It doesn't mean you can't use it in your answer, but thermodynamically favorable when delta G is negative is the preferred terminology as far as the College Board is concerned. So keep that in mind. Now we can relate the value of delta G to the equilibrium constant and also to E self over voltaic cells. You want to make sure that you know these comparisons. If delta G is negative for a particular reaction, that corresponds to that reaction having a KEQ value that's greater than 1. If this reaction is also, say, part of a electrochemical cell, cell potential would be greater than 0. When the reaction is not thermodynamically favorable, delta G is greater than 0, that means K is less than 1, and the cell voltage would be less than 0. For Nernst's equation-based reasoning for voltaic cells at non-standard conditions, we want to be able to relate the magnitude of Q and its effect on E cell. When Q is greater than 1, E cell is going to decrease compared to the standard cell potential. And when Q is less than 1, E cell will increase compared to the standard cell potential. So you want to be careful about these comparisons and state them correctly. Some final thoughts. You've been working towards this exam all year long. You've been working really hard. You've learned a lot. You need to trust in your knowledge base and your skill set that you have the information and skills you need to get through this exam successfully and get a score of 3 or higher. Remember, there are lots of useful equations and constants on your reference sheet. Be familiar with that reference sheet and use it. You will have a paper copy of the reference sheet and the periodic table throughout the entire exam. Your goal is really to be able to write down something relevant for almost every part of the test. There might be a part here and there that you're not quite sure what to do, but for most of the parts, you should be able to write something relevant down. That is really your goal. That's what you've been aiming towards. That's what all this preparation is going towards. You've learned a lot this year. Taking AP Chemistry, which is one of the hardest courses students take in high school, really makes you grow and develop as a student. You need to be confident and really take this opportunity to show what you know and how much you've learned this year. Best of luck to you on the exam.